GCSE, Year 10. Chemistry Paper, 1.
Hello everyone and welcome back to GCSE Chemistry. In this lesson we're learning about isotopes and relative atomic mass. Let's start with a key definition. What is an isotope? Isotopes are atoms of the same element with different numbers of neutrons. So what do isotopes always have the same number of? They always have the same number of protons. That's why they are the same element. What can be different between two isotopes of the same element? Their mass number can be different because the number of neutrons is different. Let's look at an example, chlorine 35 and chlorine 37. What is the same about them? They both have 17 protons, so what is different? They have a different number of neutrons. Chlorine 35 has 17 protons. So how many neutrons does it have? 35 minus 17 gives 18 neutrons. Now let's move on to relative atomic mass, also called R. What does relative atomic mass mean? It is the weighted average mass of all the isotopes of an element. To calculate relative atomic mass, what two things do we need for each isotope? We need the mass number and the abundance, which means the percentage of that isotope. So what does abundance mean? It means the percentage of atoms of that isotope in a sample. So why is chlorine's relative atomic mass 35.5, not a whole number? Because it is an average of different isotopes, chlorine 35 and chlorine 37. Now let's go through the calculation steps. Step 1. Multiply each isotope's mass number by its abundance. Step 2. Add those values together. Step 3. Divide by the total abundance, which is 100. For chlorine, 35 times 75 plus 37 times 25 equals 3,500. Divide by 100 and you get 35.5. Let's try boron. Boron 10 is 20% and boron 11 is 80%. 10 times 20 plus 11 times 80 equals 1,080. Divide by 100 and the relative atomic mass is 10.8. One important rule to remember. In any table, isotope abundances must always add up to 100%. Well done. Pause the video, practice a few calculations, and you'll be confident with isotopes and relative atomic mass.